Hello students, welcome to day 7. Welcome to day 7 of Mathematical Theory of Interest course. In this course, we will continue our discussion where we have stopped in our previous class to calculate the present values of annuity. Till today, we have calculated the present values as well as the future values of lump sum amount or uneven cash flows and the annuities. Today we will continue our discussion. We will try to understand the annuities and perpetuities, even cash flow streams. We discussed earlier. We try today in today's class we will try to uh, answer some applied aspects of these annuities. So first of all, annuity, basically we already know what is an annuity is. An annuity is a series of equal dollar payments that are made at the end or at the beginning of equity stand points in time. There are certain characteristics of annuities. First of all, an annuity is a series of payments. It has a fixed interval of time. It has a fixed intervals of time and it has a limited time period annuity. While in a perpetuity is the time period is infinity. The rest of all characteristics of perpetuity and annuity are same. Only difference is the limited time period. In annuity, the time period is limited, while in case of a perpetuity, the time period is infinity. The fourth one is the payments may be made weekly, monthly, quarterly, yearly, or at any other interval of time. But remember, the payments should be made after equal interval of time. And lastly, the evaluation of an annuity entails concepts such as time value of money, interest rates, and the future values. Now moving for the example. Here is a general example of an annuity. We have regular deposit. Remember the characteristics. We have regular deposit to a saving account, monthly income mortgage payments, monthly insurance payments, and pension payments. Normally, the payment of annuities are used in these kinds of transactions. If you are making equal payments in your saving account, that will be called as an annuity. If you have purchased a house on mortgage, then the payment of mortgage will be referred to as annuity. These are some applied or practical aspects of annuity. Similarly, in case of insurance, if you have purchased an insurance policy, then every year or every month you are supposed to make equal policy payments, equal premium payments. And pension payments is another example of annuity. So basically, when we draw the timeline of an annuity, we see that in case of annuity, the payments are normally, in case of ordinary annuity, in case of, if we simply say an annuity, it means that it's an ordinary annuity. So in ordinary annuity, the payments are made at the end of every time period. So whatever will be the total time period, the payments will be made at the end of every time period till the last period, and the interest rate or the discount rate will be fixed. This is very simple timeline to explain the annuity. We already discussed that there are two types of annuity: ordinary annuity and annuity due. Ordinary annuity. In ordinary annuity, the payments are made at the end of every accounting period, and in annuity due, the payments are made at the start of every accounting period. So first of all, we will draw the formula of ordinary annuity. This is an example of ordinary annuity. If a series of payment is made at the end of odd each payment period, then it is called as ordinary annuity. One formula is based on the payments being made at the end of the payment period. This is called ordinary annuity. This is called ordinary annuity, when the payments are made at the end of every period. Now, what about the future value of annuity? Simply, we will calculate the future value of an ordinary annuity and then add up all these values together. This will give us the future value of annuity. This will give us the future value of annuity. Assume that there are 4 from this example. This is very simple example to get the clear understanding of the future value of an ordinary annuity. There are 4 payments. Every payment is made at the end of every accounting period for 4 years, and the payment amount is $1,000 while the interest rate is 4%. And we are asked to calculate the future value of this ordinary annuity. By using the simple future value formula, what we will do, we will calculate the future value of every payment, and then we will add up all these future values together. This will give us the answer of the future value of annuity. So because there are only 4 payments, suppose there are 50 payments or 100 payments, we can calculate the future value of annuity by using this method, but it becomes very difficult and time consuming process. So instead of using this method, we will use the present value of future value of annuity formula. This is the future value of annuity formula, in which is future value of is equal to present value into 1 plus I raised to power n minus t minus 1 divided by I. Here is PVN is future value of annuity at n time period. PMT is the payment of annuity. I is the interest rate, and n is the time period. So here is an example to explain the ordinary annuity. How much money will you accumulate by the end of year 10 if you deposit 3,000 each year for the next 10 years in a saving account that earns 5% per year? So in this question, we are given the payment is $3,000, interest rate is 5%, and n is 10. We will insert all these values in this formula, and finally we can have $37,740 in our account after 10 years. Now, while solving for the payment in an ordinary annuity, what things we need to understand more? Instead of figuring out how much money you will accumulate, that is the future value, you may like to know how much you need to save each period. For example, if you are given the total future value of annuity and you are asked to calculate how much payment you need to make at the end of every period to accumulate a total sum of money. So in this scenario, you are basically asked to calculate the payments while future value of annuity is given to you. So in this example, the same situation is given to you. Suppose you would like to have 25,000 saved 6 years from now to pay towards your down payment of a new house. If you are going to make equal annual end of the year payments to an investment account that pays 7% interest, how big do these annual payments need to be? So here we will use the same formula, but here PMT is missing and future value is given. We will put all these values together and simplify to calculate the payment value. So here payment PMT is not given, which we need to determine. So after inserting all these values, we can simplify this equation to calculate the payment value, which is 3,495.03 every year per year. So in order to accumulate $25,000 at the end of 6 years, when the interest rate is 7%, you need to make 3,495.03 every year. This is how you will explain. Now moving further, how we can solve the future value of ordinary annuity by yourself. You can save $500 every month for the next 3 years. Assume your saving can earn 3% converted monthly. Determine the total in your account 3 years from now. Here the question looks very simple, but here is a very little difference. The difference is, in previous questions the payments were made at the end of every year. Now the payments are made at the end of every month. The payments, here we have monthly payments instead of annual payments. The payments will be same. What will be the interest? Interest is already 3% converted monthly, but the time year is 3 years. So in 3 years, how many months are involved? For every year 12 months, and for 3 years 36 months. So there are 36 accumulating time period. 6 accumulated time periods. So after summarizing all this, we can easily make our calculation. This is how we can solve this formula. Now the present value of an ordinary annuity. How we can calculate the present value of ordinary annuity? We discussed in the previous class. We will just simply discount all cash flows to calculate the present value of all future cash flows, or we can use the present value of annuity formula to calculate the present value of an ordinary annuity. So this is the formula to calculate the present value formula to calculate the present value of a future cash flow. So first of all, as I told you, you can simply discount all values at 0 time period and sum of all present values to calculate the total present value of an annuity. To calculate total present value of an annuity. But this is as we know that this is a time consuming process. So instead of using this formula, this method, we can use the present value formula to calculate. So we will insert all values in this formula to calculate simply. We can calculate the present value of ordinary annuity. The present value of ordinary annuity is equal to payment into 1 minus 1 divided by 1 plus I raised to power n divided by I. Here PMT is the payment of annuity, I is the discount rate, n is the number of periods. So assume that there are 4 annual payments of 1000 with interest at 4% annually, compounded annually. Now we are asked to calculate the present value of this ordinary annuity. So after inserting all this information in the present value of annuity formula, we can have 3629.90 in our as a present value of annuity. As a present value of annuity, this will be our answer. So this is all about today's lecture. I hope you have enjoyed the lecture. If you have any questions, you can ask me anytime. I will suggest you to look at the exercise of this annuities chapter and practice the question as maximum as possible, remembering the concept of calculating the present values and future values of annuities. Thank you so much. Bye bye. See you in the next class.